Hi, today I'll be going over how to create a Fresnel shader in Reality Composer Pro's shader graph. This is what we'll be creating. This type of shading is handy for adding depth and accentuating the form of an object, especially for a shader that is otherwise fairly flat, like an unlit material with a solid color. Once you're used to this pattern, it can also be used to add dimension in a PBR material by adding variation to the material's channels, such as metalness or roughness. It allows you to get a bit of a rim light effect on areas of a surface that are not flatly facing the camera. The crux of the shader boils down to this: calculating the angle between the direction that the surface is from the camera and the direction that the surface's normal is pointing, and then shading based on this angle. So areas that face the camera flat on will not be affected, and areas of the surface that point 90 degrees away from the camera, like the edges of a sphere, will have the maximum effect. A few notes in advance. Because we utilize the surface's normals in our calculation, your mesh will need to have accurate normals. I'm also going to put the source file on Gumroad as a node graph if you want something pre-made that you can play around with. Although if you follow along with the video, you'll have the knowledge to create the same file and can compose your own node graph and set it up the way you want for your pipeline. The link to the project file will be in the notes. And if you want to learn more about the math behind this, I encourage you to look online. There are all kinds of cool examples. As always, if you have questions, comments, or corrections, please let me know in the comments or on Twitter at Mr. Deerwhale. Alright, let's get started. First, let's add a few primitives to our scene. I'll add a sphere, a square, and a cylinder, and just offset them along the x-axis. Now I'll create a new custom material. I'll use the unlit material, turn off Apply Post-Process Tone Mapping, and I'll assign our 3 primitives to this new material. Great. Remember how I mentioned that the crux of the shader setup is that we need to know the angle between the direction the surface is pointing, or its normal, and the direction the surface is from the camera? Well, to calculate this, we can use the dot product, which is a type of vector multiplication that returns a single scalar value from 2 vectors. When calculated using 2 unit vectors, this will give us the cosine of the angle between the 2 vectors, which is perfect because if the 2 vectors are pointing in perfectly opposite directions, the dot product will be 1, and if the angle between them is 90 degrees, then the dot product will be 0. Let's get this set up. Add a normal node, which gives us the direction the surface's normal is pointing, and a camera view direction node, which gives us the direction the camera is pointing. Because there were bugs in Xcode 15 Beta 2 for transforming from model to world space, I'm going to go ahead and just add a transform normal and transform vector node for each of these and transform them from model to world space. Even though I'm pretty sure these vectors should be unit vectors, there's a bug in Xcode 15 Beta in which directional vectors were not normalized. So let's just add a normalized node for both of these. Okay, now we'll add our dot product node and pipe in our surface normal and view direction normalized vectors. And let's add a swizzle node to easily be able to visualize the results of the dot product node on our geometry. A swizzle node allows us to easily convert between types. In our case, we'll be providing a single float, the dot product, but we want this to create a color 3. So we'll put RRR in the input of the swizzle, signifying that the single float should be used for all 3 dimensions of the output type. Great. So now we have what we would consider a diffuse shader if the scene were being lit by the camera, in which the areas facing the camera are white, or 1, and the areas that are facing 90 degrees away from the camera are black, or 0. In the next step, we'll further the look of the shader as we utilize the same basic math setup to create a Fresnel shader. I prefer the look of the smooth step gradient, so I'll add a smooth step right after the dot. This gives us a bit more of an extreme look since we're easing out of the black values and easing into the white values. Now we want to move from this black to white gradient, and instead we'll want to utilize whatever pre-existing color the object has, and then we'll calculate the Fresnel based on that. So let's add a separate color node. Call it original color, and set it to something like this pleasing purple. Great, so now we're going to utilize this incoming color, and in order to have the Fresnel effect on it, we're going to utilize the power node. This node will take the incoming data, in this case our color purple, and raise it to the power of the second input. Because color values are expressed as float values between 0 and 1, if we raise them to a fractional power, they increase as the power input gets smaller or approaches 0, and decrease as the input value approaches 1. Let's pipe it in and maybe you'll see the results more clearly. Now go back and think about what's happening. Our dot product is getting smaller, approaching 0 at the edges, and so the color values are being raised to a fractional power, which is increasing their value, meaning that we are seeing full white at the extreme edges where the camera and the surface are at an angle of 90 degrees. This is well and good, but let's give some more control to Art Direct to the look. I'll do this by adding some range nodes to alter the values, and by adding a mixed compositing node. But feel free to experiment with other values and other compositing nodes to get a look you like. First, let's add a range node to the smooth step output of the dot product. And I'm going to have the Fresnel create a kind of core shadow on the interior spaces by bumping up the out high to 1.5. Now I'll add a mix node and have the original color piped into the foreground input and the modified color piped into the background input. Initially the mix is set to 0, so the only thing we see is the modified color. But now we'll use the same value from our smooth step to drive the mix value. As we get closer to the edges, we're seeing more of the modified color, and as we get closer to the areas facing the camera, we see more of the original flat color. To further finesse this, I'll add another range node. I'll back off the effect at the edges a bit by making the out low 0.5. And then as I was playing with these, I noticed that if I overcrank the out high to 1.5, it accentuates the core shadow of our Fresnel a bit more, although it does mean that the color in the center will be lighter than our original, as you can see here. Great, so now we have a nice little Fresnel shader that utilizes the original color of the mesh to create some depth and form. Again, you can go further and explore other ways of mixing. For instance, in the project file on Gumroad, I also created a switch where instead of utilizing just the power of the original color, you can select a specific color for the Fresnel effect, then mix this in. Or perhaps you could build something that combines both of these effects. I encourage you to explore further, and if you create something cool, I'd love to see it. So share in the comments or hit me up on Twitter at Mr. Deerwill. If this video helped you, please like and subscribe. And if you have any questions or corrections, please let me know in the comments section. Thanks.